I'll share my screen now. Yes, hope my screen is visible. Fine. Now you're all familiar with this particular website, right? VirtualLab. So here
is not yet visible.
Yes, sir.
Still down.
Okay.
Yeah, now it's fine. Now.
Yeah, it's now visible.
Okay. Fine. So now you are all familiar with this particular website of VirtualLab, right? Objectives, philosophy, everything. Fine. So these are areas over which. So now the science as well as mechanical has been discussed. So let us go to electronics and communication and electrical. So when I say circuit, you can see there are two options. One is electronics and communication, and one more is electrical. So as Sir had already mentioned, so we know of the concepts common to multiple systems. So you have concept of what used to be might be available under different domain, right? For example, now let's go to electronics and communication domain. So a concept is which is common to even electrical engineering is available for electronics engineering is available under electronics engineering domain in VirtualLab's platform. Okay. And also one more thing to note over here is some of the concepts will be demonstrated under multiple labs. So let's take an example for that. When we say electronics or electrical, basically circuit solving is one of the component, right? So for that we have multiple theorems, laws, and so on. So an example for that would be Thevenin's theorem or the other things, right? So I'll be taking you through now one of the lab called Analog Signals Network and Measurement Lab developed by IIT Kharagpur. So this is a lab. So this is a basic introduction regarding lab and so on. So I'll directly move to list of experiments. So these are the different experiments available. So let's see one of the example under this. Fine. So I'll take you to Thevenin's theorem now. So this is the theory behind this particular thing. So content covered would be similar as what you had seen till now. So one thing to note regarding this particular lab is, as I had initially explained, why this virtual lab facility could be used and what are the different ways it could be used. So one was like as a classroom activity, right? We can give multiple different variety, like different questions to different students. So as an example for that, in this particular lab, circuit remains fixed. We can have different values to each component and try to get the output values or the observation sets, right? So for example, I'll go to simulator now. Click here to perform the experiment. So this is how simulator for Thevenin's theorem looks like. Okay, so the circuit shown over here and in theory, both this are the same. Both are same. This is slightly given in a bigger way. That's it. So here is a detailed procedure. This is the circuit. Here are the different cases available. And here is the observation table. Right? Fine. So to proceed next, you can see three cases. So case 1 is to solve this particular circuit in a normal circuit solving using any of the procedure. Case 2 and 3 deals with Thevenin's theorem. Also, you can see there are two switches, right? S1 and S2. So this is basically to control input supply as well as load to the circuit. Okay. So in case 1, as I told, it is normal circuit solving. S1 will be power. I'll be connecting input supply and load to the circuit. Next step is click on simulate button. We will be getting load current. So next step is to find load current using Thevenin's theorem. So for that we know first we need to find Thevenin resistance and Thevenin voltage, right? So case 2A deals with finding Thevenin voltage and case 2B is to find Thevenin resistance. Right? So we know to find Thevenin voltage, we need to remove the load, right? So for that, I need to make my S2 as intermediate. So if I do some wrong connection and click on simulate button, you can see the error message. So I can redo the connection and proceed further. Yeah, so I'll click on intermediate now and I'll click on the simulate button. I got the Thevenin voltage. So now I'll move to case 2b. It is to find Thevenin resistance. So we know to find Thevenin resistance, we need to short the supply, input supply, right? So for that, my S1 should be short and S2 should be power. And I need to click on simulate button. I got the Thevenin resistance. So now in case 3, we have VTH, we have RTH, we already have the load resistance connected. So next step is we need to find the load current using Thevenin's theorem. So for that, I need to click on simulate button. I'll be getting the load current. So next step is to check whether the load current obtained using Thevenin's theorem and without using that, are they are matching. So for that, we need to click fill data to the table and you can see table getting updated over here. Yeah. So this is the first set of observation for these component values. So now I can change individual component value and I can get the different observation sets. So for each, just a second. Yeah. So for each component values being changed, we can have different set of questions, right? So this lab is mainly oriented for the classroom activity. So now let's see one more lab and a virtual lab platform where we can rig up our own circuits and apply similar concepts, right? So that we have a lab called Electric Circuits Lab developed by Amrita Vishwavidya Peetham. Yes. So these are again the experiments available. So you can see some of the experiments are same as we had in the previous lab, right? So let's take the same experiment over here as well. So one thing to note regarding the labs developed by Amrita Vishwavidya Peetham as well as IIT Kanpur is when we try to access simulator, it asks for login. So this is basically to keep a track of how many users are using this. So for this purpose, they had initially started this login thing. So you can create your account and using your login credentials, you can keep using the simulators whenever required. Yeah. So I already created my account. So I'll just log in. So once I log in, I'll get a access to simulate. So now to use this particular simulator, we need a simple plugin to be installed, right? So we know this Adobe Flash Player will be initially blocked by some of the browsers. So I'll click on that and allow it to run. Then I'll get the Flash Player installed and this is the simulator window what we have. So here we can rig up our circuit. Here are the components available. Here I can change its values and so on. So to rig up the circuit, I need to click on each component, drag and place it over here. And I can connect each component using this wire. If my connection is complete, it will be highlighted in black color at the endpoints. So once I complete my entire connection, I can use these measuring instruments, so non-contact ammeter, voltmeter and so on, to measure the desired parameters. So now I am getting non-contact ammeter to measure the current in this particular branch. Now since the circuit is open, I have 0 ampere as the current. If the circuit is complete, I'll get the current in that particular branch. Okay, so now I can change the way how it looks by clicking over here to schematic. I can click on show values to see individual component values. I can change individual component values by clicking on each component and changing over here. Yeah, so this is how we can rig up a circuit and apply the concept. This could be used by core circuit engineers as well as by other core branch people as well, right? So yeah, so one more thing to note over here is this particular lab, you cannot use it in a cell phone since flash plugin is required. But the previous lab, which I explained the Thevenin theorem in the first case, over there, the entire experiment could be operated in your cell phones as well. Just an internet connection is required to operate that particular lab. Okay, so with this, I think I'll conclude the present, and you will find many more labs for electronics and communication or circuit domain in new lab development portal as well. Okay, so with this, I would like to conclude the presentation from my end, and I'll hand over the session to my colleague Aishwarya Hegde.
Thank you,
So thank you.
Shrestha.
Over to you, Aishwarya.
Yeah, I hope I'm audible.
Yeah.
Yeah.
Just
Can I
yeah.
get the permission to
I stop
share my screen?
This is to transport to Aishwarya.
Yes.
Yes, sir. Aishwarya Hegde.
Aishwarya.